So once again, a very, very good morning to all. Thank you so much for joining in. And as a part of our continued webinar series or deep dives with IIQF experts, today's webinar topic is on machine learning regulatory landscape. And today's our presenter will be Sanjay. Just to give a brief introduction to about Sanjay's background. So Sanjay has done his MBA and MSc in machine learning and artificial intelligence from Liverpool John Moores University, and also has a PG diploma in ML and AI from IIT Bangalore. Is currently working as a director with UBS in the risk modeling and analytical team. So he also, involved with the model risk management and control in the chief risk office function. So Sanjay actually overall is a risk management and analytics professional with more than 15 years of mainstay experience in risk models and methodology space, encompassing Basel, advanced AIRB, IFRS 9, IMM and SSECR exposure, XVA, FRTB, OTC derivative pricing, and other advanced modeling topics. And previously, he has worked with various other foreign banks like Barclays, RBS, Citi, Credit Suisse in the risk management and consulting team. Is very passionate about teaching and particularly imparting practical model understanding and insights, and has been a professional trainer for corporate and investment banks. His areas of interest are credit and counterparty credit risk, market risk, stress testing, stochastic modeling, quantitative finance, and machine learning. And we also have had a long association with Sanjay, fortunately for us. So he is also one of our lead faculty for our financial engineering, quant finance, and particularly the machine learning for finance course, right? So with that, I'll hand over the session to Sanjay. But before handing over the session, just to give a basic laydown on how we would proceed with the session. As you all know, we would be having the talk on the topic of the day for probably about like around 50-55 minutes, and post that we would have the Q&A. So that's why I was requesting, please make the session as interactive as possible. Of course, the audience size is quite large, so unfortunately we will not be able to allow everyone to speak, but nonetheless, please feel free to type in your questions, queries in the chat window, and we would be happy to take up all your questions, queries during the Q&A session. And in fact, actually that helps us, maybe in modifying real time, modifying the talk as well. So feel free, right? And so with that, I will hand over the session to Sanjay. Sanjay, whenever you're ready, you can start, and I'm making you the presenter. No, Sanjay, you are not audible. You have to unmute yourself.
Yeah, sorry. So a warm welcome again to everyone who have joined and spare time on this crucial day of World Cup, right? That's an great, right, dedication. And today topic, I hope you are able to see my screen.
Yes, your screen is visible.
Yeah, so today topic is of specific interest, specifically when a lot is changing in the fintech regtech space. So we want to understand and we would like to know what is the regulatory take on the machine learning or AI/ML adoption across the BFSI industry. And we would also go to nail down and specifically go into the specific ask of regulation or regulatory ask, be it from BCBS, be it from EBA, be it from other prominent regulators like PRA, FINMA. What is the regulatory ask when it comes to machine learning models, and to what extent those machine learning models are what is the acceptability criteria, to what extent those machine learning models are allowed to be used for regulatory capital assessment, as well as many risk models which underpins the regulatory capital or RWA calculation, which is the PD, LGD, EAD, as you know, right? So we will go maybe topic by topic, but just to give you a flavor of how this session is structured. First, we are going to look at how mostly from these challenger or fintech companies, what has changed in the quants and analytics world, how the analytics has changed in its basic character, how it has evolved, and today analytics or future analytics, what would be the trajectory for that analytics. So the way forward for AIML driven analytics is where we start, and then we are going to see which are the most prominent machine learning use cases which are allowed to be used or which are considered by regulator as of today as we speak, right? And we definitely have many more cases which are getting developed on these sidelines, but which are the cases which are admissible as on today. Then we are going to talk about the AIML tech landscape, which means that all the techniques of AML which are heavily drawn upon while building these new use cases, or maybe relooking at the use cases where statistical modeling was previously applied, right? And then we are going to look at the regulatory trajectory, how the regulation has evolved, what different consultation papers and regulatory circulations of the material, what they have said, what are the prescriptions, and then we are going to interpret from that what is basically the regulatory focal points, which key areas the regulator is trying to focus on when it comes to AML adoption and broadly the AML validation, right? Uh, then we one of the key area which is a very burgeoning field of current future research is the AI/ML interpretability and explainability. We are going to discuss what kind of techniques are being proposed to different regulators, and what is on table, and where the research is focused on, right? And then we are going to maybe sum up in terms of what is the regtech asking from the future fintech companies or future banks, future banks which are driven by the AML strategy. So what is that? So that is going to be the structure of maybe today's session. So let's get started with the analytics. Now people generally see the analytics as one big bucket without further sub bucketing it, uh, and without even acknowledging how it has evolved through time, and where we are heading for and where we are coming from, right? So the analytics in itself has uh, brought about a tectonic shift in which we do modeling. So previously, in the yesterdays or in the gone era, we used to have descriptive analytics, which used to summarize the results based on historical or empirical data, right? So we used to drive our models or analytics outcome based on what has already happened in the history, and assuming there was an assumption that history repeat itself with most of the financial time series, be it return volatility, uh, or maybe other time series, even the correlation, covariance, dependence, the history repeats itself, right? So we used to draw our analytical insights and build models based on descriptive analytics, right? And these now maybe later on some of the new form of data has been introduced in descriptive analytics, which is a new modern data, like some of the tweet data, social media data, right? But descriptive analytics was mainly how the models were developed in the past. Then came the diagnostic analytics, right? Where rather than only looking at the historical data, we focus our attention on diagnosis of trends, patterns, uh, any key signals, any way of maybe forward looking mechanism where we could possibly build a trend line, uh, see the momentum in the random variable, track the drift in the random variable. So all these diagnostic and analysis was majorly complementary to the descriptive analytics which used to be previously there. Then come the era of predictive analytics. From here upon started the era when we most of the banks, fintech companies started evolving, and they challenge as a challenger bank, they challenge uh, the brick and mortar traditional banks by creating predictive analytics tool and models. And these predictive analytics is mostly focused upon predicting for future, predicting for longer horizon, predicting for uncertain times, predicting for downturn cycles, right? So a lot of these kind of forward looking models have been developed. You understand that IFRS 9 has changed the old metric of calculating provision, which was typically your uh, maybe some incurred loss approach with the expected credit loss approach. So that goes to the predictive analytics, that idea goes to the predictive analytics. When VAR was decommissioned under the FRTB in favor of expected shortfall, a better tail measure, that was predictive analytics. Right now, where we are going, what is the journey ahead? Right now, the area of big data, right, coming into play, huge zillions of data, zettabytes of data coming into play, and most of the firms taking as a data advantage to do data mining and create algos, uh, very advanced algos which will not only do predictive but also do prescriptive analytics. Now prescriptive analytics is the starting point was the strategy, right, how to design the bank strategy. Then a lot of other things started happening, like stress testing was relooked at, and people started talking about reverse stress testing, where rather than having a scenario, right, stress test scenario narrative given by regulator or created by some economist, why not to design a new stress test which is specifically based on idiosyncratic risk and balance sheet and P&L of the firm or the bank, right? So reverse stress testing, looking at the vulnerabilities in the balance sheet, looking at the vulnerabilities in P&L, looking at the variability of P&L, the net profit or the bottom line of P&L, right? All of those areas started emerging, and where the focus was that the traditional statistical models or mathematical models are purely assumption based and they are theory based. So we should find a new way of driving the model formulation using uh, the data. So it is a data driven way of doing modeling, it is theory free way of doing modeling, it is assumption free way of doing modeling, where we are not assuming any underlying data distribution or distribution of data. So prescriptive analysis is prescribing some of the storytelling done by the data, right? What patterns data is showing rather than what you assume to be how data should behave. So data behavior is not no more bounded by theory. Data behavior is determined by the new stream of data which is coming, where the distributions are obviously non-Gaussian, non-normal, right, asymmetric, right, left skewed, showing different tail behaviors, so different things, right? So that's the core area where prescriptive so from there upon prescriptive analytics, most of the banks also feel the dire need of revising or relooking, rebooting their strategy and business model, and making them also more analytics driven and prescriptive analytics driven. And now what we are working towards is the industry is going, the sense of direction is that we are going in adaptive and autonomous analytics, where somebody even need not to build a model, right? Once a pipeline, machine learning pipeline is created, Once that pipeline is created, all you need is to plug in your data. It's a plug and play. All you need is to you do some exploratory data analysis and data manipulation. But once your data set is created, you throw that particular data to a pipeline. It will automatically create all the models. It will auto build the models, it will auto calibrate the models, it will auto parameterize the models, it will auto validate the models, it will auto do autonomous analytics. It will create those analytics report for the models. So this dynamic way of modeling, right, where on the runtime a model is auto parameterizing, auto calibrating, auto maybe adjusting its parameters to the new set of data or new stream of data, right, auto validating, right, autonomously creating dashboards, reports, analytical outcomes, right. This new way of doing modeling is a bit of concern for reg, right. Why it is a concern? Because they say that it's a black box. They don't understand that much, right. And nor do the 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 people who are behind building these models, because some of these models like a neural network or maybe deep neural network or reinforcement neural network, they are black boxes, and it's difficult to transparently interpret and explain the output of these models. Uh, and specifically when we are dealing with high dimensionality data, it's the challenge, right. So you see that artificial intelligence, right, has now sub branched into so many areas. So it's not just uh, one aspect of artificial intelligence. And the case in point is that all these use cases, be it different machine learning techniques, supervised, unsupervised, reinforcement learning, deep learning, uh, robotics, natural language processing, computer vision, and some of the planning algorithm, they are heavily used in different areas of the bank, specifically in asset management. So most of the funds, most of the asset managers, most of the buy side firms, what they are doing is they are trying to reduce the uh, fund cost, the administration cost of the fund, right. They are trying to reduce it to so minimal that they are focusing on increasing their NAV, net asset value. But the strategy is that how could we reduce, right, the cost of doing business in asset management, right. And there they are using a lot of these machine learning application or models to automatically build a model, to automatically uh, you know uh, instantiate the model pipeline, the machine learning model pipeline, and using as much data, doing data mining techniques, using as much data as possible while they do so, right. Credit intermediation, your PD, probability of default, loss given default, exposure at default models, expected loss models, unexpected loss models, all these models, pillar 1 models, pillar 2 models, right, they are also getting very much disrupted by this prescriptive analytics as well as the autonomous analytics. uh, so is the case with algorithmic trading. The main footprint which has been created by autonomous way of building models, machine learning data driven models, is in algorithmic trading, right. So most of these algorithmic trading applications and high frequency trading applications have already been on autonomous model, machine learning based models, right. So this whole thing shows the landscape that these different areas, core areas of the banking has been very much disrupted. New business models, new way of doing business, new way of servicing your clients, new way of uh, doing strategizing or planning has emerged by using these machine learning based models, which provide key insights from data, right. And these models are very much uh, all across, front to back. So they are not confined to, say, either back office or middle office or front office, they are all front to back, right? So we have risk management models which are sitting on the back office. We have front office pricing and valuation models which are sitting on the front office. We have some limit management or pricing models, the which are provisioning models which are sitting in the middle office. So all these back office hedging, risk management, middle office where you do the uh, provisioning or the credit administration, or maybe the risk appetite decision, or maybe some of these kind of things, that is also been very much been swayed away by the machine learning advancement. And so is the front office model, where we do the derivative pricing, or the calculation of some of the other things like CVA based pricing, credit valuation adjustment based pricing, or right. So the front office derivative valuation, pricing, and all those aspects have also been very much disrupted by this huge wave. Right now, what is the tech stack? Right now, ought to be knowing the tech stack, because we named this session Regtech. Right. So there are many EBA papers, European Banking Authority papers, Fed Reserve papers, PRA papers, FINMA papers, and out of this, what I collated maybe is presented here, that these kind of different techniques of AI and ML, right, are now being seen favorably by the regulators. Regulators could be super regulator as well as the national regulators, right? So super regulator means Basel or EBA, and the national regulators like Prudential Regulatory Authority of UK, FINMA, which is Swiss regulator, Fed Reserve or Monetary Authority of Singapore, or APRA, which is Australian Prudential Regulatory Authority. All of them, right, they are looking at these, right? And the bucketing is mapped to the previous district map, where you could see that, right, there are machine learning models as well, there are NLP models as well, there are computer vision or computer audition models as well, right? But the focal point is the machine learning models, where maybe many of these models have started gaining traction with the regulator, right? And So these technologies, or these tech techniques which are being harnessed by various uh, analytics professional in banks and fintech companies have been acceptable, reached to an acceptable standard in the regulatory eyes. So that's the core point. And the other part is that you might know that as the fintech ecosystem is growing, more and more fintech companies are springing up. The entire the BFSI industry is trading volumes. You take the lending footprints, peer-to-peer lending or other kind of lending mechanisms which are purely data driven. So the fintech companies are the lead runners, and as the fintech companies are growing, the regulator also feels pressure to come out with a alternative version of the regulatory institution, which is called Regtech, right? So the Regtech is also adopting these models, these techniques, to verify the models, to validate the models, to benchmark the models, to do the quantitative impact analysis or study on the models created by various or submitted by various banks to these regulators for their approvals. So so it's not just the market is changing, it's the regulator itself. Will tomorrow's regulator, the Gen Z regulator, will not be uh, same as Gen X regulator. So the Gen Z regulator would be purely a techie firm, right? Inside out, it would be a technological outfit which would be enforcing the regulation on machine learning AI adoption, for various application of finance, quantitative finance, risk management, financial engineering, derivative pricing, all these areas, algorithmic trading, right? So it is also changing its DNA, right? And these technologies are now well used because in other areas, uh, like even astrophysics or pharmaceutical sciences, or maybe uh, bioinformatics or other fields, these have some, and even in automobile, like self-driven car or whatever, right? These the results from these techniques are very, very, very encouraging, right? So so the business use case, although it's not well established within BFSI, but it is established somewhere else, and that business use case is no less complicated than BFSI business use case. So it makes sense to apply these techniques to our data sets. The only thing challenge there is that financial data is unlike the other data, where the financial data presents its own daunting challenges, which are that financial data is uh, very heterogeneity. Time heterogeneity means that the distribution of the financial time series change from time to time. It is not same, the movements of distribution will not be constant, right? So that is not generally when you talk about the e-commerce data or other, even the pharmaceutical data, that is not the case, because the financial capital markets are very thriving, and every then and now, they go through different cycles, and they go through different crisis period, boom period, bust cycles. And there's a the financial time series also react differently. Suppose return series or price series react very differently under these cycles, right? So there's a turning of cycle effect, right? So which makes the data very heterogeneous, time heterogeneous. It is no more time homogeneous, right? The data is very scarce, very less. Though you keep hearing that a lot of data has been mined and is already available in the data lakes of bank, but the modelable data, the data which could be used for modeling, is still very scanty. And these machine learning models are very data hungry monsters. If you don't train them with adequate enough of data, you will get very spurious results, right? So the challenge is doubled, that we need to have huge amount of data to train a machine learning model vis-a-vis a conventional statistical model. And the data is which is coming is not very much of high quality, specifically in financial industry. And even if it is whatever data we have, we need to panel it, because the data is very, very time heterogeneous, right? So the data scarcity, the data maybe verifiability is a problem, a challenge, as well as the core character of the financial time series, that it is time heterogeneous and not time homogeneous, right, is also a challenge. Then the financial data has a lot of noise, right? So the noise to signal ratio is very high in financial data, which is unlike itself apart from other forms of data, right? And the role of a machine learning model is to separate the signal from the noise. But when the noise is very high, the financial time series are very noisy. See the volatility clustering patterns. You will examine any return time series from any asset class, you will see that it's very noisy, right? So separating out that noise from signal, the machine learning models which are built by for financial application need to do a lot of uh, more you know uh, workhorse, or maybe more labor work in order to churn the data, in order to mine the data, in order to find real analytical insights in the data. Sorry. So that brings us to what is the regulatory landscape. right, where it is going, and how the regulator has from time to time intervened and come out with a consultative paper or a regulatory prescriptive paper or some kind of regulatory guidelines or circulations which are being published officially, right, to inform that what is the expectation around these models. So it all started very recently, it's not a long back phenomena, right? So the regtech evolution, the where the uh, regulator is adopting this technology. By the way, the term regtech means that a technology enabled regulator, right? So the regtech is evolving, and in order to adopt the AIML and big data technology by the regulator for doing the model development and model validation and the model impact analysis, right, the regulator has come out with a lot of prescription, right, and this is captures the mainstay of prescription from the European regulator, which is EBA, European Banking Authority, right. So in December 2018, which is around start of 2019, right, so they form the EBA form a joint committee, right, with member states, right, all the European Union member states to form which is specifically focused on AIML, right, adoption within the financial sector, right. In Subsequently, the corporate default forecasting models, right, were being considered by the EBA as valid models when a machine learning technique is being applied. So that's maybe the second thing which happened, right. So after that, maybe so now the probability of default or the corporate default models or the wholesale rating models have are admissible when you are working you are submitting a model for approval to EBA, right. So EBA recognize that the machine learning models, be it random forest models or some boosting models or some decision tree based models, are acceptable. Even the different form of doing regression, which is machine learning way of doing regression like lasso and ridge, is also very much acceptable. So now we submit the model with regulator. When we uh, do some part of the modeling using ML technique, it is acceptable by EBA, and so is with national supervisors within the European region like PRA, FINMA, they also have an acceptance of these models, which was not previously the case, right. So then a high level in Feb 2020, right, so there's a white paper which you couldn't find online, it is a public document, which is white paper on AI, right. It was commissioned the European Union Commission published this white paper to promote and address AI challenges, concerns, considerations. uh, that is also one of the paper which has been cited in many of the subsequent research papers, right. uh, the AI, the there have been other expert level, high level expert groups which were formed, right. And there's a new area which came into picture, and where the regulator has given and coined a new term called the KTI of uh, AIML. KTI means key trustworthy or transparency indicators, right? So when the regulator is examining these models for approval, right, these KTIs, which we will cover in subsequent slides, will be specifically looked at, right, in order to take a decision whether to approve or disapprove a model, or to approve a model with certain condition or with certain margin of conservatism, right. So it has further mapped these KTIs, key trustworthy indicators or key transparency indicators, with certain margin of conservatism as well. That if ML model, if you trained a ML model with less data than what is required, right, to draw a meaningful interpretation, then there would be some margin of conservatism you have to build in your final estimates. So these are being very much explicitly looked at while approving these models, right? And then European Commission has also harmonized certain standards, how these models should be developed, how these models should be designed, how these models should be maintained, how these models should be validated, how these models should be confirmed every year, how these models should be submitted to the for the regulatory approval for that is also where many supervisory authorities are following European Commission's published proposal and guidelines, right? Uh, and then there are certain analysis from time to time, like EBA also published very recently an analysis on Regtech landscape in EU, right, which highlights some of the uh, crux which we are going to cover in subsequent slides. Then there's a discussion paper on internal rating based approach and how to build AIML models for these advanced IRB, internal rating based approach, which is PD, LGD, EAD models for use for regulatory RWA and calculation, right? Uh, and the BaFin has also recently published a good paper called Big Data and AI, right? uh, to highlight some of the inherent risk or some of the implicit challenges in building the big data, adopting the big data and artificial intelligence and machine learning technologies within the fintech and regtech space. And now you can see that where we are heading. So the explainability and interpretability of artificial intelligence models, specifically when used for default modeling, when used for time series forecasting, is the key area of focus going forward for all these regtech innovations, regtech ideation topics. This particular thing features everywhere, and we are going to have a few specific slides on this topic because it is an area of research by very prominent ML researchers as well as industry consultants, uh, and also it is in close doors with the regulators that these things are getting evolved, right? Right. So uh, so this slide just captures what is the qualitative expectation of the regulator from these models, right? So the first thing first, as one should have the team who build these models should have the right kind of skill set and sufficient knowledge to develop and validate these models. So now when we go to the FINMA or go to PRA or go to EBA or go to Fed uh, for any regulatory approval, we need to attach our CVs as well, right? That okay, we are really a data scientist or a machine learning expert building these models. So it's not a Tom, Dick, Harry job, right? So we so that they could anytime challenge on that if there would be some journalist who is trying to build these models, who doesn't understand how to develop these models, design these models, and validate these models, right? uh, we need to explain the risk drivers very clearly, so that's on our reports which goes to the regulator when we submit these models for their regulatory inspection, right? The risk drivers, as the challenge with AIML models is that they assign certain weight or certain coefficient, they determine certain parameters of the model in a very convoluted sense, right? So that convoluted sense, sometimes you are unable to explain why a particular factor, right, why a particular variable got this weight in the final model specification, right? So that is one of the area where regulator has asked that you publish the a dedicated report to explain why different variables, risk variables, have got different parameters or risk factors when it comes to a machine learning model, vis-a-vis if the same model could have been developed with the statistical modeling, how the parameter estimation would have changed, right? So and the other thing is that in machine learning presents a lot of techniques, right? Within supervised learning, if you count, there are good 28 odd techniques which you could use for the same use case, like credit risk modeling. Now out of that, these huge number of techniques, you need to have clear economic rationale why you are using a particular technique than other. So a general approach which is being followed is to apply multiple of these techniques, like 7 8 of them, compare the results, uh, do the benchmarking with the either the champion model, which is a statistical model, or the external benchmark model, which is coming from S&P, Moody, Fitch, right? Do a benchmarking exercise, and whichever model appear to be a clear winner in closely aligning with the market benchmark and the internal benchmark, uh, could that technique, like say random forest or ada boost or light gbm, that technique could be adopted, right? And there's a lot of focus on documenting the outcomes of machine learning models, like what are the key drivers of machine learning models, how they model non-linearities or multi-collinearity, right? Is there any assumption with respect to data, when you did the data manipulation for ml model built out? Is there any assumption you have taken, right? uh, so that is bucketed, all of this has been bucketed as model knowledge, right? So you need to publish report, you need to publish additional data to the regulator, you need to clearly set out your assumption, limitation, sorry, restrictions and weaknesses of the model, and you need to clearly pinpoint, right, how you have built that model, what kind of data has been used, what methodological choices you have made, all of that, right? Then the regulatory expectation as on date is that these models should not be too complex, right? Which could change, right, as things will evolve, right? But as on date, that it should, because ml models are good at churning a huge amount of data compared to statistical models. uh, ml models are good at solving high dimensionality problems. So these sometimes, the ml models are labeled as greedy algorithms, and the greediness uh, comes from the fact that they try to overfit the data, right? They try to overestimate, they try to over parameterize, they try to come out with more number of variables to explain the same output than a statistical model, right? They try to also use a lot of unstructured data, which is a very cutting edge advantage of using AIML models, that it can process or use the unstructured data, which is like your textual data, which is like your tweets, which is like your sentiment analysis, all of that, right? And it inherently takes many complex modeling choices, and so it brought in unnecessary complications into the model, and some intricacies which as on date a regulator could not wrap his head around. So there's a separate dimension where regulator will assess the complexity of these models, right? uh, the the third bucket I have already you know maybe alluded to, which was that these models should be easy to understand, interpretable, explainable, right, transparent, right? And we will talk more about this in specific measures in subsequent slides, right? So that is another area. And then a lot of other forms of focus area is how to validate these models. It's not about one off exercise of developing, building and deploying these models, but once these models are designed, developed, built and deployed, how to do annual validation, model validation, or model risk management, right, around these models, how to identify overfitting issues, how to keep challenging the model design, how to see that the model stability over time, how to see the representativeness of the data used for modeling, right? So all of these aspects are with respect to model risk management and model validation, which is again it is consumed in a separate report which goes to the regulator, which is the model validation report for the respective AIML model, where we are required to specifically argue and elaborate on all these aspects, right? So so the focal points are summarized here, right? And they are the key trustworthy indicators, KTIs, of artificial intelligence and machine learning, right? The KTI is model design and structure, right? Model design and structure, the transparent documentation, transparent and clear documentation, the complexity and efficiency of the model, right? The stability and robustness of the model, both to data, the changing changes in portfolio, changes in market scenarios, right? The data quality and governance, which means maybe that whether what kind of the specifically with unstructured form of data, which is the video data or the textual data or the speech data or the tweet data or the sentiment data, right? These kind of data, what kind of data quality controls and data governance the bank is adopting, because it's been for the first time that if the model is approved model, not only the model is approved, the data which is used to build that model is also approved, right? So the other part is human oversight. The emphasis has been given that how qualitatively some human or some team can oversight these models, right? And what would be the criteria or consideration based on which they will be providing their oversight and review of these models. Interpretability and explainability I have already covered, right? Of these models, and that goes a long way, and we have a few dedicated slides because that's a future area of maybe evolution, interpretability, and explainability of AIML models, representativeness of the underlying data set, overfitting issues, these greedy algorithms, right, tend to overfit, over explain, over parameterize, over calibrate, maybe how to solve resolve that those things, those issues. And the fairness, the outcome of these model should be fair and consistent with some of the accepted economic theory. Like if you say the modern portfolio theory, right? If you say that there's a some theory behind maybe a theoretical explanation about Merton default model, or right, some credit risk theory, or portfolio risk theory, or market risk theory. So the broader theory, how fairly these model aligns to that particular theoretical understanding of the market, how market works, how the price stays in equilibrium, right? Different concepts like martingales, or maybe martingale pricing, or mm, it's basically uh, tying back the model to the theory, right? To prove its fairness, right? Okay. So as said that maybe the main thriving area, or the main burgeoning area of research is the interpretability and explainability of these models. So first of all, you could see that many of these models, like which are very, the challenge is that the high performant models, right, or the learning algorithms, ML learning algorithms, uh, on this plot you could see that they have the least explainability. So if you talk about deep neural networks, they have the least explainability. They are most useful, right, in pulling a lot when it comes to complex problems or complex use cases, but they are least explainable, right? Similarly, the support vector machine, which is a non linear classifier and an alternative to doing logistic regression or probabilistic regression, right, is very good at doing the non-linear classification. But explainability, challenge is a challenge there, right? Some of the while some of the uh, you know uh, those models which are closer cousins of the statistical modeling and a bit of machine learning on top of it, right? uh, and they are near to how we used to do modeling, but with few things which have changed, like decision tree have been built into random forests, their explainability is very high, right? So the new area or the literature which is emerging uh, to address this problem of uh, AIML explainability and AIML interpretability is called explainable AI, right? XAI, right? So if you nowadays, if you just type the word XAI, you will find that a lot of firms are or a lot of consulting firms are specifically, or product companies are specifically built around uh, developing tools which will help uh, doing explanation of the AIML models, right? So there are two techniques, and I have a bit of simplified this thing as well for everyone to understand. First is model agnostic. First is assuming that all AIML models, right, irrespective of which model you are talking about, are black boxes, right? So when you assume that all AI model are black boxes and you want to compare results across these pack of AIML models, suppose I have built a random forest and want to compare result of random forest with extreme gradient boosting, or maybe uh, some other model like light gradient boosting, right? Or maybe some other technique like support vector machine. If I want to compare the results, so I will be using the first set of uh, mm, uh, tool sets which are called, fall under the model agnostic way of explainable AI, right? Right. So it doesn't go too much into how the that specific model work internally, but it metrics put up some metrics on top of the models where the explanation from one technique, ML technique, could be compared with other techniques, right? So a new form of sensitivity analysis has been developed, right, where a few of the ML variables are perturbed or changed to see what would be its impact on the output. So that's one way where a lot of uh, you know uh, ML models are examined and explained. But the problem with this is sensitivity analysis. It's the same sensitivity analysis which you do for your current models, and you might have heard that in market risk we calculate a lot of sensitivities, right? And for models, for different models, we calculate different sensitivities, right? But the problem is that sensitivity analysis falls short because it does not capture the interaction between variables, right? So when you build an AIML model, the main idea was to overcome the drawbacks or the misgivings of the statistical models, and those were that statistical models fall short of capturing multicollinearity and interaction between variables, right? And the also the anyway the statistical models assume linearity between all set of variables and your dependent variable or the target variable. So all those things are overcome by the machine learning model. But mm, when you do explain the machine learning models, you have to again use some form of technique which is very much aligned with how the model is developed. So that way of new way of technique, there are two techniques which are called the Shapley values, Shap values, right? The Shap analysis we called it, and these are based on game theory, right? Where we explain how each variable which the model has estimated, how it is contributing to the output of the final output coming from that model. So one is the Shapley analysis, which is based on game theory, how in a game each player contribute marginally, so it's a marginal contribution, each player contribute to the winning of the game. So each variable, how it contributes to the final output. So that is one technique. Then there's a lime framework, local interpretable model agnostic explanation, which is the full form of lime, right? So here we fit some kind of a local explainability, where the features or the variables are explained locally. Locally means not across the entire data set, but in the subset of the data set. Because if a variable is behaving differently, or there are some kind of non-linearities which are hidden in the subset of the data, right, then Lime would clearly make that transparent and explain why this variable has got more weightage or relative weight or than other variables, right? So so Line technique, tries to capture the interaction among these features or variables, right? It generate a simplified model, right, which learn from the changes in that particular variable, changes in multiple variables on the predictions, right? Uh, it explain the model through the simple model, which is a local model, right, rather than a global model. Global model, not the entire data set, not, it is not explaining the output of the ML model on the entire data set, but it is explaining the output of the ML model where it matters the most, where the non-linearities or multi-collinearities or some of these interactions, are hidden, right? Uh, and The idea is to explain the ML model better, explain the output like neural networks, how it achieved, so many features, and what kind of importance or significance it assigned to so many features. So that could be explained through this line, right? Then model specific is like if somebody want to do the technique testing when you submitted the model, let me go back. So here I'm combining two things: model structure. The regulator will ask you, explain me the model structure, explain me the interpretability and explainability of the model. uh, it means that explain me what the technique is doing, right, what the formulation is doing, how the what the function is doing, and also explain me, right, how the output is created, both explanation. Then I will combine a model agnostic as well as a model specific technique, and the model specific technique would definitely be that I could use another model, another algorithm like decision tree or random forest or neural network to train it to explain the outputs of my main model, right? So that is model specific way of doing it. So these things, as I said, that this is still an area which is under evolution, which is undergoing a lot of research and experimentation, and a lot of maybe consultation between regulators, consulting firms, the AI firms, right, AIML firms. So it's an evolving field, but just for you to know that this will be the future of AIML when it comes to the BFSI industry and the Regtech and enabled business model. So in crux, just maybe here in crux, the data model, you have to explain to the regulators the data model, right, use for the AIML, right? How the data model is not just about the describing the data, right, the structured and unstructured data, but how that data is distributed, right? What is the empirical distribution of that particular data, how that data is controlled, how the data quality is managed, how it is traceable, the data traceability, all of that. The conceptual soundness, which means the model design, model structure, right? The how to the model automatically recalibrate itself, automatically determine its parameters, what is the technique, what are the functions which the model is using, how the model is transforming the variable, what kind of transformation are being applied by for one particular ML technique versus other, right? So all these are the conceptual soundness, as well as explaining the model output, the model evaluation results, model output also, in terms of the SHAP values, or the Lime framework or the sensitivity analysis. And then the going into a loop, how a separate set of requirements or prescription, regulatory prescription is focused on how the validators or the model risk management team is managing the risk of these models, on a continuous basis, right? So the it talks about the annual validation exercise on the models, how you validate, how what kind of tests you will perform on these ML models to validate their output from time to time, how you when the data changes, whether the model is still relevant, the model stability, the model maybe robustness, the model comparability with its benchmark, right? All these topics are maybe covered through various KTIs, key trust worthy indicators, and KPIs, key performance indicators, to assess the performance of the model. It also sometimes, to a limited extent, allows the model validator to test the model using the synthetic data if the real data is challenged, which is the case in the financial domain, that the real data is challenged. The sparsity or the scantiness of real data restrict us from testing the model thoroughly, right? So we could use the some form of synthetic data as well, right? And obviously then the comprehensive documentation and the use of the model. So this documentation also, now the clear guidelines have emerged where the regulator has said the documentation should clearly capture the assumptions, key limitations, key restrictions, right? Key weaknesses of the model, right? And those need to be clearly set out, and then some kind of uh, testing should also be performed to check whether those assumptions, limitations, restrictions, weaknesses, right, are taken care by appropriate margin of conservatism into your model, because it's a regulatory model. You cannot go wrong with your capital assessment or capital adequacy assessment. So what kind of margin of conservatism you are baking in your models to overcome any deficiencies in data, any deficiencies in modeling technique, any deficiencies in maybe certain transformations you applied, right? Any deficiencies in some a part of data where you augmented the data, where you were lacking the data, but you augmented it by using some synthetic data. So all for all deficiencies, you ought to have some kind of margin of conservatism, which you need to clearly document along with the assumption, limitation, restriction, and weaknesses of the model. Yep. So that maybe concludes what maybe I have to maybe cover, but happy to hear from you. Maybe it would be better if we open up for the Q&A session and hear from people what doubts they have and what they would like to know more about. Yeah.
Yes, absolutely. So, I mean, thanks first of all for another wonderful, insightful session. It was really deep and helpful, I guess, for the participants. And I have questions, but before going into the Q&A, to give you a breather as well, and just to introduce about us and the work that we have been doing. So basically, allow me maybe a couple of minutes of 3-4 minutes time, and then we'll go into the Q&A.
Sure, sure.
So before we go into the Q&A, just allow us to maybe briefly talk about the work we have been doing and the things, the courses that we do, which somebody who has an interest in getting into this kind of machine learning related areas in finance and other quant analytics areas, they can utilize the courses that we do, right? So just to start with, as you all know, I represent Indian Institute of Quantitative Finance, and we are a body which is dedicated to education and training in the field of quantitative finance, financial engineering, risk management, quantitative algorithmic trading, and courses related to artificial intelligence and machine learning. And we were founded by pioneers in India and top experts from the field of financial risk management, financial engineering, and investment banking. And as I mentioned, we have been an education institute which has been at the forefront of quant education for more than a decade, almost 14, 15 years now, right? So for people who are interested in making a career in the field of advanced quant analytics, risk management, machine learning areas of finance, we have a lot of very broad-based certificate programs which prepares you and makes you ready for jobs in this kind of advanced analytical fields. These are courses which not only prepares you theoretically, but more importantly, our courses has been well appreciated in the industry for the practical modeling that we teach. So since today's talk is related to machine learning topics, so I would like to start the introduction of our courses with the course dedicated to machine learning in finance. It's called a certificate program in machine learning for finance. Yeah, I mean, all these courses that I will be discussing, I mean, these are all courses which are done through online live interactive sessions on the weekends. So, I mean, you can do it along with your job, or if you're pursuing any other degree, you can do it along with it as well, because they're weekends and done through online live lectures, so you can attend from anywhere. And of course, every lecture is recorded as well for future reference. So coming back to the course, the first course that I was mentioning was the Machine Learning for Finance, an 8-month certificate program. And this course is designed for teaching machine learning and data science in context of applications in finance. So, I mean, we have seen there are like multitudes of machine learning courses offered by many institutes globally, right? But rarely do we see a course which teaches machine learning in context of finance. And since we have been at the forefront of, I mean, advanced financial analytics and I mean, into a lot of quant analytics research, and I mean, a lot of work we have been doing in machine learning. I mean, we and all our faculties have been in the forefront of the industry. So, I mean, we thought it's about time that there has to be a course which dedicatedly teaches machine learning in context of finance, because as with every other field and finance, particularly in fintech, in credit analysis, in derivative valuation, pricing, risk management, algorithmic trading, machine learning is a huge area. I mean, and people, there's a lot of requirement for having an understanding of like the machine learning and its applications in finance, particularly in international banks. I mean, Sanjay, as you know, he works with like a team which applies a lot of machine learning in his areas, right? So that likewise, most international banks, hedge funds, and all other financial institutions, I mean, machine learning is used heavily. Other than that, of course, I mean, we being a quant institute, there are dedicated courses for people who want to make a career as quants, particularly into quant analytics, risk management, and related areas. So for people who want to make a career in the quant domain, there are a couple of courses. One is a course called Certificate Program in Quantitative Finance and Risk Management, 6 months course which comprehensively covers and deep dives into both the theory and practical modeling for derivative valuation and risk management. Then there's a course called Certificate Program in Financial Engineering, a 7 months course, which deep dives into both theory and practical modeling for derivative valuation and risk management. This QFRM and the CPFE, these are both courses in the same domain, with a little bit of difference in the orientation. FE being like a course which is more heavier into the covering the mathematics in deep. The QFRM relatively less mathematical and more broad-based course on quant, which and a more focus on risk management. Then another area in advanced quant analytics and in related areas is algorithmic trading, very hot domain. So if somebody wants to learn algo trading in deep, we have a couple of courses. One is a postgraduate program in algorithmic trading, which is an 8 months course, and which teaches all aspects of algorithmic trading using different kinds of strategies, technical analysis, price action-based strategies, machine learning, and quant models. And there's a shorter course in algorithmic trading, those who want to concentrate on learning algorithmic trading using technical analysis and chart-based, pattern-based trading. So there we have a course called Certificate Program in Algorithmic Trading, right? And I mean, so I'm not going deep into the machine learning or the other courses at this point of time. Anybody who wants to discuss in detail, have an interest in this, we'll be happy to discuss it one-on-one. Our contact numbers will be shared here, and then again, you can always go to our website and contact us. So, I mean, yes, since it's a machine learning based webinar today. So I mean, just showcasing the modules and the career track that one can look at if somebody is doing a machine learning related course from us. So the potential career revenues are available in the industry for aspirants of this machine learning program. So you can become a data scientist for financial accounting decision systems. You can go into machine learning model or becoming model designer for financial forecasting and predictive models. You can go into forensic audit data science. You can be a fraud analytics machine learning expert. You can be a risk finance compliance machine learning data engineer. You can be a machine learning modeler for quantitative more financial models. You can be a machine learning driven algorithmic trader, and you can be a machine learning model validation expert. So all these roles and more, I mean, it can be targeted in this. And of course, I would like to add that though the course is more dedicated for machine learning applications in finance, but at the end of the day, it's a very strong deep machine learning course. So even if somebody is not particularly interested in applying machine learning for finance, they can still do this course because once you know machine learning in deep, then of course you can apply to any industry, right? So you can actually apply to other industries and machine learning as well. And for all our courses, we have a strong placement support, which starts even before the course starts, right? So when we discuss with you about the course, we there itself we start with your career counseling. So we understand your background, we explain which course is ideally suitable for further progressing your career, or I mean which area you should be entering into. I mean, even before you join our course, there is a career counseling support that we do. Then of course, once you're in the part of the course, then the industry experts who are faculties for different courses, they provide you a deep career mentorship. There's a dedicated placement support team who works day in and day out, I mean, with the different quant, risk management, machine learning related teams in different financial institutions, be it the international banks or big four consulting firms or hedge funds and all, and other financial institutions. They continuously network, they get the job opportunities, and they for the students side, they do individual profiling of the students, and then they send their resumes to relevant quant and risk analytics and machine learning related profiles where according to your profile it's best suited, right? And yeah, I mean, being the oldest quant body in India, we ourselves are from quant domain, uh, and then the faculties, they are all leading experts from the industry. The students of the last 14-15 years, a lot of them themselves are like in deep I mean very senior positions. So the industry connect is pretty strong, and then as I said, we have a dedicated team which continuously keeps in touch with the different hiring teams, right? So I mean, there's a strong network of industry association which you can all utilize in case you are successfully doing any of our courses. And then I mean, as a part of the things, I mean, while we're doing your profiling, we do your resume building, profile improvement, and then help you connecting with the right companies, right? So uh, we have a strong channelized way of like helping you with all that, right? And I mean, we have been fortunate to have a lot of people from the industry coming through our courses in the last 14-15 years, right? So this is just a very small list of people who have been kind enough to share their experiences. Just for it's not to market our courses as such, but it is more to for you to showcase, like you can go and read their testimonials, see their videos, so that you can understand how different people have utilized these courses for making a career in this field, right? So there are a lot of them. This is just a small list to just to highlight this fact. I mean, you can go to our website and see the testimonial page for that, where you can actually go through their whatever thoughts they have shared. I mean, in terms of companies which you can target by doing this kind of courses, I mean, you can target all the top international banks, top hedge funds, or other Fortune 500 financial consulting firms or big four consulting firms, etc. Companies like hedge funds like Renaissance Technology, DSO, Citadel, Millennium Partners, the investment banks like Goldman Sachs, Morgan Stanley, Deutsche Bank, commercial banks like JP Morgan, Citibank, Nomura, and then stock exchanges, of course, like NYSE, NSE, uh, big four consulting firms like EY, Deloitte, PwC, KPMG, etc., and even the IT companies for their specialized teams related to the international banking and other financial institutions, companies like Accenture, Cognizant, TCS, etc. Right? So, I mean, not going deep into the types of job you can target, you can pretty much target any job related to quant, risk, or machine learning by doing this kind of courses. Over the years, as I was saying, industry association has been like a very strong point of like our journey, right? And it's like a very small list of companies where we have worked with in different capacities, being their trainers, consultants. I mean, a lot of them hire from us companies. As it's just like a very small example list. The association is with pretty much most people who are working in the quant and risk analytics space, right? And yes, in our endeavor to promote the quant finance and related areas in India, I mean, we have worked with the academia as well for institutes like IIT Bombay, BITS, Pilani, NITI, to name a few, where we have tried to spread the word related to the quant and the scope of the industry, right? So, I mean, yes, we have been doing our bit to promote the quant finance field, and I would like to think that, I mean, in some way, big or small, we have been also been, I mean, has been a part of the progress of the quant industry in the last like 1.5 decade. Right. So in case anybody gets interested in any of our courses, or you want to discuss anything, even if you don't want to, I mean, directly explore courses, you want to discuss anything related to your career and how you can place your journey in this quant or risk analytics or machine learning related areas of finance or algorithmic trading for that matter, you can contact us. This is our website, www.iiqf.org. You can call us. It's one of the numbers, 8976993622. You can contact us, and of course you can email us to info@iiqf.org. So we would be happy to guide you, discuss with you, and take any questions, queries in one-on-one. So now, like there are a lot of questions from the participants. So let's like maybe take up the questions one by one. So I will collate the questions for you, Sanjay, and then we would answer the questions one by one.
Yeah, sure.
So first question is from Saurav. So Saurav mentions, I mean, this question was probably in context of a particular topic that you were discussing at that point of time. So if you are able to decipher the question, please answer, or maybe I'll tell Saurabh to elaborate. So he mentioned, what about the algorithms that are already in place and applicable in the current scenarios? So do you get the gist of the question, or shall I tell Saurabh to maybe broad best?
Okay, so let me give it a go, and then maybe if sort of your question is not answered, then maybe you let us know, right? So I think
Absolutely.
you are maybe specifically asking that what will happen to those models which are already part of productionized those AI/ML models, how they would be subject to regulatory requirements. I think in that
Right.
context, yeah. So most of the AI/ML models as on today are not regulatory approved. They are used for internal risk management purposes like limit monitoring, or maybe even pricing, or even maybe risk appetite or risk tolerance determination, or some kind of there are a lot of strategy models as well, right, which are typically based on what would be the client or customer strategy in one area or the other, asset management or the other, or there are multiple portfolio management model as well. But if you are using any of these models for a regulatory outcome, like the capital adequacy or the stress testing CCAR stress test, or maybe the ICAP requirements or Dodd-Frank Act, right? it, for any regulatory purposes, if you would be using these models, then it is must to get these models approved and examined by the regulator, for which whatever we discuss is the moot point. How to do your regulatory submission, and how to comply with the regulatory requirements for AIML models. Yeah.
Right. So yes, Saurav has confirmed actually that that is exactly what he was trying to understand. So thanks for that. So Saurav, I hope we have answered your question. I mean, if you have any follow-up question, you can always put it up. And the next question is from Ramesh. Thanks, Saurabh. All right, so next question is from Ramesh, and he says that why noise to signal ratio is higher in financial data.
So generally, the financial data has few, very how to say, peculiar things which is not generally seen in other forms of data. Other forms means coming from other industries, right? The financial data has first of all the market microstructures, right? So the market, there's one systematic structure of the market, but within the market there are typical microstructures, right, which basically changes the nature of the financial data in subsets, right? So these microstructures of the market, right, requires you to not only build a model but to do some data modeling on the data as well. Because when it comes to from when you take the data cohort spanning multiple years, spanning multiple segments of the financial data, you will see that there's an effect of micro market structure on the financial time series. The second aspect is that uh, when it comes to the market data, be it your price series or return series, generally the volatility and the clustering nature of volatility, which we call that it is heteroscedastic, right, will make the data presented with a lot of noise. Because every time the volatility will sometimes show in short span, it will show certain patterns, which is just the noise, which is not a signal. So your trend might not be, or your drift momentum might not be in that direction, but it is just a spike or a blip in the data, which is owing to the fact that the volatility clustering is there, right?
Right.
So some of these unique things make your data a lot noisier than the other comparable data sets in other industries. Yeah.
All right. Yes. I hope that answers your question, Ramesh. So if you have any follow-up questions, please feel free to put up. In the meantime, next question is from Sarvana, and Sarvana asks, yeah, so he mentions that coming Thursday I have to attend the ML interview, but I'm confused how to be ready, and I'm a fresher. Give me some key points. So before answering that question, Sarvana, I mean, if you are able to hear, would you be kind enough to give a little bit background about yourself? So when you say you're a fresher, so what degree did you pursue? I mean, you are from a finance or from engineering or any other discipline? So can you just type in quickly, Sarvana? All right. So he is from statistics background. Yeah, I mean, so yeah. So do I repeat the question, or did you
No,
get the
no, I
question?
got it. I got it. So since you are fresher, so I think specifically I will tell you those algos or models which you should, in such a short span, if you get a good overview of those, read bagging and boosting algorithms, right? Because that's mostly used, as well as somebody who is coming from statistics, you would be able to build on what you already know, like how to create a random forest out of a decision tree, or how to use a boosting algorithm. So this is part of a learning called ensemble learning in machine learning. So if you can just read through ensemble learning in machine learning, and the bagging and boosting specifically, right, in such a short span, at least you would be able to say that you have uh, some idea about machine learning, though it might not be enough, but still. Yeah.
Correct. I mean, I hope that helps actually, Sarvana. I mean, of course, going further, you might need to do if you are been targeting machine learning related profiles, so you may have to do more reading. But yeah, in a short span, I think it's a good suggestion. Right. So next question is from Vikas, and he has asked, EBA has started accepting machine learning rating models. I mean, he wants to elaborate. Please elaborate.
Yeah, so that's the case. That previously, prior to COVID, right, it wasn't the case. Maybe I don't know the exact reason, right, why the change in mind, but we have previously, not we, but generally, the market participants have previously submitted these kind of corporate default or wholesale rating models, PD rating models to the regulator, but they were very skeptical about it. But post COVID, right, again, another characteristics of noisiness in the Financial Times series is post COVID. If you compare other data series with Financial Times series, right, the Financial Times series has exhibited quite a noise, right? So that's why maybe post COVID or during the COVID period, while doing the impact analysis, the regulator themselves use the machine learning techniques to do the quantitative impact study, so they become a little comfortable. And then during that period, they took time, their sweet time, to come out with some prescriptions or guidelines, which we discussed today. And now they are a bit on a positive side, so they have moved from their position, from being skeptical to neutral to more forward looking and optimistic about the adoption of these models for uh, financial applications. Yeah.
Right. Wonderful. So I hope that answers your question, Vikas. So Saurav has another question actually, and he asks that what were the roles shown in Nitish's slide that a machine learning aspirant go for? So Saurav, I would make this question a little bit more machine learning specific, right? So my slide that you saw actually was like more about the entire quant and risk management industry. So what I will request Sanjay to guide him about, like, again, what are the different machine learning related roles that that he can target in finance.
Yeah, good. So, if you are coming from an IT role family, and if you suppose hypothetically you hone up these skills and become a machine learning expert or a data scientist, right? So, it depends, because your core field, if you're coming from engineering, computer science, or IT field, you could take up a machine learning engineer role, right? Where you would be required to, you would be expected to know the technique and code it in some analytics language like Python or Julia or Perl, or maybe specifically Python, right, because it is very potent for machine learning, right? So uh, uh, and then there's another role called machine learning researcher or machine learning scientist, right? That is more focused towards those people who are coming from statistics, mathematical background, and who know the inside out of the technique, the methodology of machine learning. So when somebody decide like which technique from the shelf should I apply for this use case or that use case, a machine learner, researcher, or a scientist brain is borrowed, right? And then there are many roles in the data science or data scientist field, right, which talks about how to create data sets for machine learning algorithms or AI application. So that also you can explore, somebody can explore. But all these requires a good understanding of machine learning, because you know that these 21st century roles are these are very creamy jobs. There's a dearth of skills, though there's an some degree of accommodation that people have, you know are not expected to know everything, but they are still expected to know a reasonable amount of technique, how the mathematics behind these models, and how these models really work. And they should have done some kind of experimentation around a specific model for which they are evaluated for. Yeah.
Absolutely. So I hope that explains your answers your question, Saurav. Right. So now, okay, just a minute. So he says that he is an engineer MBA from Bangalore, and Python I shall be shortly learning. Um, okay, I mean, lightheartedly speaking, I mean, you may definitely look at our certificate program in machine learning. It is dedicated to prepare you for those roles. But anything you want to add, Sanjay?
No, no, definitely. So we have designed this CPMLF program just because of the reason, although we all this while on various other courses which Nitish showed, we have been teaching machine learning as a module for specific application to risk management, derivative pricing and valuation, algorithmic trading, and all those topics we have been teaching. But this course, the intent behind this course is to prepare you from scratch, be it your programming skills. Uh, that is not only limited to knowing Python, but also some concepts of programming, the mathematical skills, where we provide some, dedicated sessions for knowing the statistics, mathematics, probability behind these models, AIML models, and also knowing then obviously your mainstream understanding of these techniques, which is designed in such a way that we will cover all the supervised learning, semi-supervised learning, unsupervised learning, reinforcement learning, deep machine learning, natural language processing under different modules. So it is a very comprehensive course, and somebody who wants to become a full-bodied data science or machine learning professional, uh, and specifically, uh, although there are other good courses in the market as well, but we make sure that this course build certain strong use cases for the financial problems and the financial data sets and the banking problems, be it from risk management, derivative pricing, and algorithmic trading and other areas. So that's also one unique thing, that we have a use case library where we exhaustively cover these use cases and do some scratch up implementation of the models of ML solution for these use cases. So that's maybe a brief about the course itself. But maybe if you would like to explore more, definitely Nitish would you can have a chat with Nitish, and he would maybe address those specific things where you would be much more informed about this course. Yeah.
Yeah, absolutely. Right. So, yeah, I mean, we would not hold people much longer. So maybe we'll take like two, three more questions and then we'll wrap up the session. It's already about time. But anyway, like people probably would be going to for the World Cup match today. So very quickly, couple of important questions. So I'll combine questions from two people. All right. So let's, if you can try and answer together. So Rajesh is from an engineering background, working for a couple of years in IT, and Mitesh actually he is from a pure finance background, a commerce graduate, then working in certain pure finance areas, right? Both of them wants to move into machine learning. So Mitesh has a more doubt actually. I mean, he mentions that being from a non-coding or non-technical background, I mean, would he be considered for a machine learning role? So I mean, we can answer this one by one, or like we can combine them as well.
Okay. So I'll like to combine them, but it would be answering those specific questions, right? So
Sure.
first thing first, right? The industry is evolving, so it's not that you will find data scientists or machine learning expert uh, and that I'm talking globally, right? It's not about India. If you see, what is happening in Zurich or Frankfurt or London or New York, right? It's the same kind of thing. People want, the financial institution want to go all big bang about these machine learning adoption, AIML adoption, because it's in their competitive advantage. They have already strategized for it. But the biggest challenge they face is there are no resources, trained resources or people. That presents more opportunities than entry barriers to people coming from different areas, because obviously even main universities like Wharton or Oxford or Cambridge or Massachusetts, they still don't have a full-fledged machine learning course, right? So it presents a lot of opportunities for those people to learn quickly, to turn around, learn quickly, adopt, get some new skills. It doesn't really matter you have never done coding in your past. The only thing is that coding is not in a low level language like C or C++ or C sharp or Fortran. The new day coding is very intuitive, right? Like the coding you would do in Python, but still the concepts, coding concepts or programming skills need to be developed, right? But it's not a new thing that people who have been working in traditional roles in finance, in middle office, in back offices, have over time and are taking up taking it up seriously and picking up a course and start doing programming and coding and also developing mathematical skills. So it's a journey, but I think if somebody focus is lens focus and is have conviction to do it, right, in a year or two, maximum 2 years time, you could maybe spin it off, right? You could maybe turn around yourself into somebody who would be taken seriously as a data scientist professional or as a machine learning expert, right? And then a lot will come from practice. You are not new there, right? There are people who know coding, but who doesn't know anything about machine learning. So it's a new thing for everyone, right? So that's no advantage or no entry barrier for a specific set of people or the other, right?
Yeah, absolutely. Particularly just to add for Mitesh, I mean, Rajesh, anyway, you have like a IT background, so of course the programming is relatively easy for you. But as Sanjay rightly mentioned, Mitesh, I mean, uh, since things are based out of modern languages like Python are relatively easy to learn, and I mean, a lot of people from different backgrounds, finance, even medical people, and then people from other backgrounds, they actually are able to learn this field and make an entry, right? Because I mean, the trend. I mean, this is like still a relatively new field, so I mean, there are not many trained manpower. So if you can build your skills, this is one field, unlike most of other fields where actually it is difficult to move around, right? So this is one field. Even if you come from a different background, if you have built your skills, you actually will be able to move. I mean, nowadays there are a lot of ways to showcase your skills as well, even if you do not have like a practical experience to show. So, for example, I mean, if once you learn the things, you can actually create your capstone projects. I mean, your codes and all, and again, you can upload them in various places like GitHubs and all that, and like you can showcase that you actually know how to do things, right? So there are a lot of places. I mean, in LinkedIn and all, you can share your updates and again your highlights of the projects or the things that you have built, and that way again you can easily attract employers, and we are there to help you in case you are doing one of our courses, right? So I mean, all in all, summarizing, I mean, this is very exciting time for people who want to enter into machine learning, and I mean, whatever background you come from, if you can actually make a serious effort in learning the field, there is a scope for everyone, to be honest, right? So I hope that answers both of your questions. So now going into the question, probably this will be the last question. Let me just check. Uh, okay, couple of questions we would be taking. All right. So the next question is from Arunachal, and he has asked, are any de-biasing steps mandated in the pipeline at the level of algorithm or dataset from the lens that AI models can reinforce existing social financial biases? Is there any scope of integrating positive discrimination, uh, within brackets, affirmative action in financial pipelines? Example, boosted creditworthiness of tribal entrepreneurs. Uh, yeah, so if you have, can you answer that question for him, Sanjay?
Yeah. So I think what you are trying to, I'll simplify your question first. So what you are trying to ask is that is there any bias correction uh, that can be built as part of the autonomous pipeline, ML pipeline? Uh, and is there a way we could correct for the biases in data, right? The
No, in
modelable
fact,
data.
actually, he has. In fact, Arunachal has add few more pointers. Yes, that is correct. He has mentioned, and he has also added that uh, he is a physics grad school dropout working as monitoring and evaluation expert for learning products and non-profits. So completing my MS in data science, aiming for a transition to ML-based fintech, more inclined to regulatory aspects, ensuring equitable social outcomes through fintech services. So just thought I'll add that in his background. Yeah. So if you can kind.
Okay,
So yeah.
so I'll give you an example. I don't know. You might be talking about some community. models, right? The tribal models and those kind of models. But if you read into stuff from IMF and World Banks, right, they are also heavily using machine learning nowadays, right, to promote community banking, as well as in the area of climate risk. So climate risk is one area which is again thriving, which is where a lot of people are trying to use machine learning. Now, why I'm telling you this, because the bias factor, the high biases, uh, is very prevalent in climate risk data, right? When we collect data, right, we not only collect the meteorological observations, we collect a lot of other data as well, right,
Yeah.
which are different measures to ascertain how the planet is warming, how the ice is depleting, icebergs are depleting, and the biases are very high. So I don't know, I won't pretend to be knowing everything, but I don't know whether, in general, we could build a bias correction mechanism in the pipeline for every data set. But it again depend upon data set to data set. If that bias, what you are referring to, is generic to the entire data set, it doesn't change from, doesn't have a local effects, means change from subpopulation to another subpopulation, then yes, it could be built into the ML pipeline and automated it. But if it has a localized effect, right, it change from subset to subset, subpopulation to subpopulation, that bias change, then you need to handle it as part of the exploratory data analysis or data manipulation or data transformation. You need to apply some data transformation strategy to correct for that biasness before creating that data set for and throwing it to the models. Yeah.
Yeah, absolutely. So I hope that answers your question, Arunachal. Yeah, yeah, our pleasure. Thanks, actually, that we are happy that actually we could answer your question. And yeah, Saurav has mentioned that though he's an engineer, he also doesn't know coding. So that's okay, Saurav. As we mentioned, I mean, in current yes, ways, I mean, things, I mean, you can always build your background in terms of coding. Particularly, you can start with Python, which is relatively easy to learn. Nonetheless, it's a programming language, so you have to do some work. I mean, it requires practice, but it is doable. I mean, if people who are from totally, I mean, different background, finance and other areas, they can learn programming and they can become data engineers, data scientists, and machine learning experts, then you definitely have a much better chance. Only thing is, yeah, it will require a little bit of dedication and effort, no doubt about it, right? But yeah, it's possible. So, I mean, I think with that, we have come to the end of the questions for the day, and I hope we were able to answer all your questions. And so with that, we will try love to conclude the session for the day. I mean, as I said, we would not like to hold you much. Maybe most people are waiting for the World Cup final match to start. So yeah, let's conclude the session for the day. First and foremost, thank you, Sanjay, once again for taking your time out and for the wonderful session. It was very insightful. Thank for again answering all the questions in detail. And to the participants also, thank you so much for joining on a weekend, particularly on a match day with the World Cup final coming up. So, I mean, yeah, it shows your enthusiasm. Wonderful to see that. So very glad to have such a wonderful participation. And I mean, as you all know, we regularly keep conducting lot of webinars on different important areas of finance, particularly quant risk, algo trading, machine learning related topics, and all other areas of advanced financial analytics. So, I mean, please keep track of us through our website, through our social media pages. You will also receive intimations of the new webinars that are coming up through email as well. So hope to see you in all our future webinars. And again, once again, thank you all for joining. Thanks, special thanks to Sanjay for taking your time out. With that, let's conclude the session for the day. Thank you.
Thanks. Cheers.
Cheers. Thank you.